One of the most important points that you should understand about Ethernet is the role of carrier-sense multiple access collision detection in your network environment. The idea behind Ethernet is that it utilizes a bus topology. We've got a single main backbone cable, which is terminated on both ends. Plugged into this cable are all of the systems. Only one system is able to transmit at a time because you can think of this backbone as a one-way street by default. Think of a one-way street with buses that run in both directions and actually are picking up passengers on both sides of the street, which are actually the computers that are plugged in. At some point, there's going to be a collision. Now, if you can tell those buses that they have to wait before they actually drive down the street till there is no other bus on the street, they will be able to make it to whatever their destination is without actually having a collision. The idea or the role of carrier-sense multiple access collision detection is that we will talk to the other buses. We will, in other words, look for a clear line. Multiple access indicates that multiple systems would be able to access the wire. They will actually listen on the wire to see if a transmission is currently in process. If there is a transmission, this system will not be able to transmit. Let's say that system A is transmitting on this wire. If system D were to listen to this wire and hear the transmission using the carrier sense method, and will continue until nothing is heard on the wire, at some point it will begin or attempt to transmit. Now, if for some reason multiple systems transmit at the same time, there will be a collision of traffic. This is where collision detection can occur. The collision detection process is actually a back-off algorithm where a jamming signal is set for a period of 10 microseconds. The idea is that if we have detected a collision, we're going to go ahead and back off. We're going to then try to sense the line again to identify if the line is clear to transmit. If it is clear to transmit, we will try to transmit again. If this is successful this time, then obviously the collision detection function has done its job. But the more systems you place on an Ethernet network, especially in half-duplex mode, the higher the likelihood that we're not going to have clear lines to transmit, or the lines are going to be very congested, and that we are going to have a lot of collisions. The extent of the segment size for which these collisions can occur is what's known as the collision domain. The size of the collision domain is identified as the number of systems it can actually affect by a collision, because if they are all on the same collision domain, they are all seeing the same collision. Therefore, we can have significantly reduced efficiency, significantly reduced data throughput on each and every network. One of the reasons why we get into network design and get familiar with networking technologies is that this information can help us improve the issue of collisions. We'll actually notice that one of our main objectives is to shrink the size of the collision domain. That is, shrinking the effect of the collision. If a collision domain can be brought down to just a single port instead of being the entire network, that means we're going to have much less overall effect from collisions themselves on our data reliability and our data throughput.